Hello class, my name is Maya Hayes, and Tyrena Webb and myself will be presenting today on the observation of particulate matter 2.5 in ozone in California from 2001 to 2013 using the EPHT network data. I will now begin by discussing the abstract for our study. California has proven to be a very progressive state in the United States, especially in the case of addressing environmental issues. In fact, in 2006, California introduced the Global Warming Solutions Act. This required the state to produce a climate change plan. The plan's overall mission was to provide a firm limit on emissions, reduce vehicle greenhouse gas emissions, improve appliance efficiency standards, preserve forestry and agriculture, reduce the use of high global warming gases and their related chemicals, and move towards high recycling and zero waste initiatives. Our goal is to identify the impact of this act and the related initiatives on ozone and particulate matter 2.5 using the EPHT data for California for the data ranges 2001 to 2006 and 2006 to 2013. We chose these time periods because it was a 5-year time period prior to the act being established, and then a 5-year time period following the act being established. Our results from the observation represented a decrease in both ozone and particulate matter 2.5 from the time period 2006 to 2013, which is the years following the establishment of the Act. Since climate change results in adverse effects globally, understanding the impacts of this Act and how it improves the air quality of California will allow us to advocate and implement initiatives used in this Act in other areas with poor air quality. In doing so, this helps to support the overall concern of environmental health and the impact air quality has on it. I will now begin by discussing background information that is relevant to our study. So the Global Warming Solutions Act, or also known as Assembly Bill 32, is a California state law that was signed in on September 27, 2006. The Act fights global warming by providing a comprehensive plan to reduce greenhouse gas emissions from various sources throughout the state of California. California found a demonstrated need for the Act through research that showed anthropogenic climate change is both a significant and growing problem globally. Climate change is the result of various greenhouse gases that are emitted into the atmosphere, for example, carbon dioxide and methane, which both have a heat-forcing effect on the atmosphere. Rises of greenhouse gases have led to an increase of global temperatures along with global fluctuations within temperature and precipitation, and it's also caused a global sea level rise, along with more frequent extreme weather events such as hurricanes, heat waves, and droughts. The California Air Resources Board stated that the Global Warming Solutions Act of 2006 was the first program in the country to take a comprehensive, long-term approach to addressing climate change, and it does so in a way that aims to improve the environment and natural resources while maintaining a robust economy. Assembly Bill 32 is a very detailed and comprehensive act. However, a major requirement of Assembly Bill 32 is that the state's global warming pollution be reduced to 1990 levels by 2020. Other key initiatives include regulations be put in place for mandatory greenhouse gas reporting for industries, identification and adoption of regulations for landfills, motor vehicle fuels, refrigerants in cars, tire pressure, port operation, and other sources, the adoption of a low-carbon fuel standard, and the establishment and appointment of an Environmental Justice Advisory and an Economic and Technology Advancement Advisory Committee. So major initiatives for implementation for the Act began in January 1st, 2008, and implementation deadlines actually continue through to December 31st, 2020, which is the deadline for the global warming pollution to be reduced to 1990 levels. The objective of our study was to identify the impact of the Global Warming Solutions Act of 2006 and related initiatives on ozone and particulate matter 2.5 using the EPHT network data for California for the dates 2001-2006 and 2006 to 2013. I will now begin by discussing our study's methods. So particulate matter 2.5 and ozone were observed using the EPHT monitored and modeled data. In order to identify the current status before the act and observe any significant changes thereafter the passage of the act, we chose an observation period of 5 years prior and 5 years after the passage of the act. We chose this observation period because key implementation deadlines for the act were not really enforced until 2008. We also chose this observation period because 5 years would allow enough time to observe the impact following implementation deadlines. After the raw data was extracted from the network, we chose to create line graphs using Microsoft Excel to observe any significant trends. Additional data was then chosen to be represented through the use of bar graphs and maps as reflected in our following results section.
Hello, my name is Tarina Webb and I'll be going over the results section. So for this first graph, we see it shows the dates above regulatory standard of particulate matter 2.5 in different counties of California from the year 2001 to 2013. Overall, the trend is that you see a decrease in particulate matter overall in California across pretty much all of the counties, but there was 4 major points and a significant decrease in counts in Los Angeles, Placer, Riverside, and San Diego. And this decrease is believed to be due to the California's Global Warming Solutions Act of 2006. Now, into this picture, we're going to be looking at maps of particulate matter 2.5 in California from 2 sets of years, so from 2001 to 2006, and to 2006 and 2013. And these maps were also generated using the EPTH software. So in 2001-2006, this year was chosen since this was when the Global Warming Solution Act was introduced, and we wanted to see what led up to the implementation. So we wanted to see the trend before the act was established in 2006. So overall, there was some improvement in air quality in some areas, and those areas are denoted by the arrow. But this could have been part of a smaller, more localized initiative to improve the quality of air by the specific county or regulated by that county. But you can also see by the circles that some areas have gotten worse also, and this could have been due to the environment of the city. So were there more factories, more cars, more traffic coming in, etc. Now looking at the bottom set of graphs from 2006 to 2013, those years were observed to see the effects of the act. So we couldn't go all the way out to 2020, but we wanted to have a set amount of years, so a large amount of years, to see the overall effect and compare it to the previous years. So overall, a greater amount of areas have improved air quality overall since before the act was set into place. And mainly you can see that in Northern California, it's projected to have greater air quality. You can see that with the star, and these are just projections anytime you see the X's on the map. Southern California, the air quality seems to be the same and not has changed as much since 2001, and those are denoted by the circle. And this could be due to the environment of the city. So maybe there was a lot more traffic or just extreme amount of air quality, or that's just the lifestyle of the county overall. So now let's look into the ozone results. And here we have a graph that represents the number of days the ozone measurements were above the regulatory standard. For each county, there is a notable decrease in the number of days the ozone measurement was above the regulatory standard. And we suspect that this is also due to the passing of the Global Warming Solution Act by California in 2006. And the reason why we think that is because if you look at this chart, which displays the total number of days annually, ozone was above the regulatory limit. For years 2001, 2006, and 2013, you can see since the implementation in 2006 that the amount of ozone has decreased significantly, leading us to believe that this was due to the passing of the Global Warming Solutions Act. So just to sum everything up, overall there was a decrease in both ozone and particulate matter 2.5 from the year 2006 to 2013, which leads us to believe that the Global Warming Solutions Act of 2006 has been working to improve the air quality in California. And since the implementation of this act, there has been a 14.7% decrease in air pollution as of 2016. And if this trend is true, that means that the act should reach its goal of decreasing air pollution by 25% overall by 2020 for the state of California. Now I want to go over some potential intervention and prevention strategies to reduce the exposure of particulate matter 2.5. So PM 2.5 can be reduced by establishing wildfire reduction and containment protocols. So since wildfires are responsible for approximately 2,500 deaths due to the exposure of the fumes annually in the US. To prevent this issue, regulations have already been set in place in California to decrease the amount and aggression of wildfires. An example of this would be the Department of Forestry and Fire Protection in California established a shutoff plan, which basically entails shutting off all the power anytime it's a condition where it could spark a wildfire. And this is beneficial since it focuses on the containment of wildfires after it started, resulting in substantially less particulate matter being expelled into the air. Now, what we can do to prevent ozone is by implementing regulations and policies that actually reduce vehicle contributed greenhouse gas emissions. So, for example, as a part of California's Global Warming Act of 2006, the state required the adoption of low carbon fuel standards and mandated efforts for clean transportation standards. And this was beneficial since it challenged car manufacturers to create vehicles that met California's strict standards. This intervention was awesome because it led to the drastic reduction of the number of days of ozone above the regulatory limit. So now the limitations of using the EPTH software. So it was useful because it was user-friendly and straightforward. So after a couple of minutes playing around on the website, it's pretty easy to use. There are a lot of options to choose from and what you want to do, and it gave maps to visualize the effects chosen, which was very helpful. Some of the difficulties of using the software is that it didn't have current up-to-date numbers or projections, which made it difficult for us to kind of break our years apart with our data. Graphs and charts seemed inaccurate or confusing, leading us to kind of make our own, and there were a lot of projections in my topic resulting in inconclusive data. So these are the references. And if you have any questions, let me know. But I hope you enjoyed our presentations, and I hope you have a good day. Goodbye.